In this case study, we're going to follow Carlos, a tomato producer in South Florida, and look at a real-world problem involving ethylene and fruit ripening. This example connects directly to what you just learned about ethylene's role in senescence and development and shows how plant physiology is used every day in agriculture. Carlos harvests his tomatoes green and firm so they survive shipping without bruising. At his facility, he uses ripening rooms and exposes tomatoes to ethylene gas to trigger ripening before they're sent to stores. The problem is timing. Some shipments arrive still green, while others arrive overripe and too soft to sell. Even small changes in when the tomatoes are exposed to ethylene or how long they stay in the ripening room seem to make a big difference. His goal is simple: get tomatoes to the store ripe at exactly the right time. Ethylene is unique because it's a gas, and it plays a major role in fruit ripening and senescence. In agriculture, it's used intentionally to synchronize ripening after harvest. Just like with auxin and gibberellin in earlier activities, both the amount of hormone and the length of exposure matter. Too long, and the fruit can become overripe. Too short, and the fruit stay green. This is the core of Carlos's problem. Carlos isn't deciding whether to use ethylene, he's deciding how to control it. When should the tomatoes be exposed? For how long? And how does that line up with shipping and delivery schedules? This is really a timing and regulation problem, not an all or nothing one. This should sound familiar from your ethylene experiment. Ethylene accelerates ripening and aging, but development doesn't just depend on whether a hormone is present. It depends on how much, how long, and how the tissue responds. Hormones don't act like simple on-off switches. They work through careful regulation, which is exactly what Carlos is trying to manage. Pause and answer the reflection questions. As you answer these, start with the practical side of farming. First, why does Carlos harvest tomatoes before they are fully ripe? For question 1, think about shipping, bruising, and spoilage. Second, what role does ethylene play in tomato ripening? For question 2, connect directly to what you learned about ethylene as a hormone that promotes ripening and senescence. Third, how could controlling the timing and duration of ethylene exposure help Carlos? For question 3, focus on timing and control. Adjusting when and how long ethylene is applied could fix the problem. Fourth, what might happen if tomatoes are exposed to ethylene for too long or not long enough? For question 4, think in terms of too fast versus too slow development and what that means for fruit quality. Last, how does the case connect to the holly branch ethylene experiment? And for the last question, connect this back to the holly branch experiment and how ethylene affected aging and tissue changes there. The key takeaway is that ethylene is used deliberately to control ripening after harvest, and that timing and exposure length are critical. This case shows that plant hormones regulate development rather than just triggering it, and that the biology you're learning in this lab is used every day in real agricultural systems.